In this video, we're going to learn about boxplots. There are a couple of things you need to be able to do with boxplots. The first is to construct one, and I'm going to show you how to do that first. And the next is how to interpret one that's already been drawn. So let's have a look at this question. You may remember boxplots from GCSE. They're things that look like this. Okay, so there's a box in the middle, and there are these things called whiskers coming off the edge, and there's usually a line somewhere in the box. Now, the key features of this is that we've got the minimum point at one end, we've got the lower quartile at one end of the box, we have the median in the middle of the box, or that's the line represented in the box, we've got the upper quartile at the top of the box, and then we have the max value here. So that's how we usually drew box plots at GCSE. At A-level, we add in a little bit of extra detail, which is the following. Rather than this picture, we often want to represent outliers in our box plot as well. So you'll often see box plots that look like this. There'll be a little X somewhere, and then a box plot, and then maybe a few more X's like this. Now, what are these X's here? Well, these are the outliers. So these whiskers, where do they go up to? Well, you actually have a choice here. They either go up to the upper bound of the cutoff point for where an outlier lies, and the lower bound here, or they go to the highest value which isn't an outlier and the lowest value which isn't an outlier. If you need a recap on outliers, go back to my previous video on outliers. Okay, so we're going to draw a box plot that takes this into account. So I want to represent this data in a box plot, but I want any outliers to be represented as an X, and I'll take my whiskers up to the last bit of data that wasn't an outlier. So first thing to do is actually work out which are the outliers here. So I'm going to use the standard definition, which is that an outlier is one which is more than 1.5 interquartile ranges away from the upper and lower quartile. So that's going to be the upper quartile plus 1.5 interquartile ranges and the lower quartile minus 1.5 interquartile ranges. Okay, let's first work out what the interquartile range is. So I've got the upper and lower quartile here. So the interquartile range is the upper quartile minus the lower quartile, which is 14. So to find the boundary for a outlier at the top end, it's going to be the upper quartile 63 plus 1.5 interquartile ranges. So that's 63 plus 21 here. So that is 84. So anything bigger than 84 is an outlier, and I can see that I've got one outlier here, 110. And at the lower end, it's going to be the lower quartile of 49 minus 1.5 interquartile ranges. So that's 49 minus 21, which is 28. And none of our data is lower than that, so we have no outliers at the lower end. Okay, so that means that the only outlier I need to represent on my data is this 110. So here's how I'm going to construct my box plot. The left-hand whisker, this bit here, is going to go all the way down to the minimum point because the minimum point isn't an outlier, so it will go all the way down to 32. Then my lower quartile is at 49, so I'll draw the start of my box there, and so this whisker is going to connect to the box there. Then the median, I need to put that in, a line at my median, so that's at 58, which is here. And then also I need to put the top of my box at 63, so I have a line at 63. Okay, let's give the box a base and a top. So that box there contains 50% of my data because it captures everything between the lower and the upper quartile. Okay, now rather than extending my whisker all the way up to 110, I'm going to put a little cross at 110 to show that we have an outlier up there. And then I'm going to extend my whisker all the way up to 70, which was the last data point that wasn't an outlier. Now, you can extend it up to 70, or you can extend it up to the boundary for outliers, which is 84. It doesn't matter which one you do. So it's really up to you. I personally think it's a bit clearer to take it up to the last data point, which wasn't an outlier, because it gives you a sense of how much this one was outlier by, how much beyond all the rest of the data it was. So that means my top whisker is 70. So that's where I put the top of the whisker, and there we go. And I kind of like that method because it shows you how much of a gulf there is between this number and all the others. All right, so that's how we construct a box plot. So just remember it's representing 5 points of your data, which is minimum point, lower quartile, median, upper quartile, maximum point, but we also need to consider outliers. So that's what these little X's are. All right, let's have a look at an example of a box plot so we can see how we would analyze one. So here's the question. Each of 60 students was asked to draw a 20-degree angle without using a protractor. The size of each angle drawn was measured. The results are summarized in the box plot below. Can we find the range of these data? Well, the range of the data is just the biggest value minus the smallest value. Now we can see that there is an outlier up here, but that is still one of our results. So that's the biggest value, and that's 48. So our biggest value is 48. And our smallest value, well, there are no X's down here, so there must have been no outliers at the bottom end. And that's a 9 there. So we do the biggest value minus the smallest value. And so 39 is the range of that data. So the thing to watch out for there is to not go up to this point here, because this point here is just the biggest value, which wasn't an outlier. That's the biggest value. Now, what about the interquartile range? Well, the interquartile range is just the upper quartile minus the lower quartile. Well, my upper quartile, Q3, is 25. And my lower quartile, Q1, is this point here, which is 12. And so my interquartile range is 25 minus 12, which is 13. Okay, so that's how we can analyze a box plot there. You are frequently asked to compare sets of data. So suppose that there was a part C of this question which said a different group of students were asked to draw a 20-degree angle without using a calculator, without using a protractor, and for them the information is as follows. Let's say that their lower quartile was 18, their median was 21, and their upper quartile was 25, and you're asked to compare the data. The two things you always want to talk about when you're asked to compare data are the average and the spread. Make sure you comment on those. So for us, we can compare the averages, and we could say, well, for this group, the average was 16, and for this group, the average was 21. So we could say the average was higher for this group. We could also say it was on average better because their average was closer to the real angle they're aiming for. And what about the spread? Well, the interquartile range for this group was 13. For our other group, it was 25 minus 18, which is 7. So a much smaller interquartile range, so that would be more consistent. So always make sure when you're asked to compare data sets, you compare both the average and the spread of data. Okay, I hope that's given you a refresher about how to represent box plots, and now you understand how we represent outliers as well when we're drawing and interpreting box plots.